we can get started. Welcome to the first Weather Watch of 2025. My name is Patrick, if you don't know me. I will start with a week-long view of the infrared over the CONUS and Atlantic. So this is looking at temperatures that the satellite sees looking down towards the United States, Caribbean. A couple things to point out. First, at the start of this loop, all of this green, yellow, blue, this is our Arctic outbreak. So the satellite is seeing temperatures on the ground that are as cold as clouds moving through. So how you differentiate is you can see first, this mass kind of, it grows, and then as the sun comes up, it goes back to the Arctic, grows back to the Arctic. It's also not moving. So you can tell that and make that distinction. And then as it encroaches down towards the plains here, this next one, you can make out some topography. So some rivers, the Snake River, I believe that's in South Dakota, the Platte River in Nebraska. So that's how you can differentiate between what's just Arctic air and what's clouds. But you can see this cold air has lasted for a while. Even this morning, that last image was this morning, we got below zero. And you can see there's a little bullseye of the cold air right over Wisconsin here. So that's one thing to point out. This is the Arctic blast we had. This Arctic blast was the producer, one of the producers of snowfall over the Gulf Coast. Hopefully you've heard of that by now. Winter storm warnings all the way from Texas to Florida, which has never happened. Blizzard warnings along the Gulf Coast never happened. There were images of 6 inches of snow right next to the Gulf of Mexico. Wow. Just crazy. Some of these places, especially Louisiana and Texas, this little corridor here, got as nearly as much snow as we have had all winter. They got it in one day. That's really disappointing for us, I think, because we were cold, we were super cold, and we had no snow to even show for it. Meanwhile, the Gulf Coast is having 2 days of snow days and having fun and enjoying it, and we're just sitting in brown and gross and cold.
I'm really glad that AMS was last week.
Oh yeah, it would have been a nightmare.
Oh, God. However, that would be pretty cool, the first blizzard warnings for New Orleans. Same time all meteorologists are there. New Orleans tripled their daily snowfall from this event. Tripled. Daily snowfall
record.
Yeah, wow. Daily snowfall record, tripled.
I think it's also like the first time they got snow since the year of Katrina.
Yeah, it's been a while.
20 years.
You can see I saw a map of the year-to-date snowfall. This region doesn't even show up because they don't get snow. There's no year-to-date snowfall along the Gulf Coast. So even though they have 6 to 8 inches of snow all along this region, it doesn't show up. There's just no record for it. It's only once in 10, 15 years. What else you can make out from this loop here? Could you stop it, please, Pete, and just go back to right when it's snowing here?
I think the White House is going to declare by executive order no snow in those places ever again.
Probably, I wouldn't put it past it. Keep going back, please. Right here. So if you could just mouse back and forth right along here. What I want to point out, the reason it snowed on the Gulf Coast, it's really cold over the continental United States. Here's your moisture. So you can see, usually when we get Arctic blasts, no moisture, air coming from the Arctic, you can see these really low clouds. Here's your moisture. When these two collide, please go forward, keep going, and boom, there's your snowfall begin. Right where those two coincide, the moisture is just tied to the Gulf Coast. That's the only thing that's moist this time of year. And here we have our 6 to 12 inches of snowfall along the Gulf Coast. Pretty significant and fast moving. This is only a day worth of snow, but enough to still shut down parts of New Orleans yesterday.
Yeah. And no particular cyclogenesis at all in that period. Later on, it looks like you start to get a little bit of a wave over Georgia, South Carolina, but over the northern Gulf of Mexico coast, there was no wave. It was just all tied to transverse circulation around the jet, I bet.
Exactly, right. Activity. That's mostly, it was just a band that moved slightly northward. Wow. There you get your snowfall. This actually becomes something important that I'll talk about that's currently going, since this is a couple days later, but I'll get to that in a second. So that's for the infrared loop at least, that's what we've seen in the wake of all the Arctic air. You can see, if you scroll forward, here's significant lake effect. Directly eastward, you can see parts of Lake Huron, Michigan, Lake Michigan, and then Lake Superior all getting lake effect snow from this Arctic blast. Here's our snowfall that we had 2 days ago, 1 day ago, just light snow over us. And then right at the end, we had a little bullseye of cold air right over Minnesota, Wisconsin. So that's for the weekend recap from just this loop here. Could we please go to the climate page? And we'll look at something interesting with the Arctic blast we just had here. So if we look here, here's temperatures for Madison starting January 1st, 2025. You can see we had 50 degrees, and then we dropped down, I believe we got to like this says minus 13, I believe, at the airport. So significant drop in temperatures, and this seems to be a pretty clear pattern. If you look at both the climatological lows and highs, you can see there's a decrease right around mid-January, mid to late January. That's exactly when we had our decrease in these temperatures. If we scroll down to 2024, same thing. That exact same region, exact same time period, we had very cold temperatures. A little colder this year than last year. Looks like we only got to minus 11. But then we get a warm up. So interesting that it's happened 2 years in a row now at least. Same type of scenario. Then if we scroll up to our snowfall, you'll see how sad it's been. If you weren't in Madison for the break, this is nothing. I mean, this is like 2 inches, maybe 1 inch of snowfall the entire break. We got 2 inches just right when we came back to school, and that's it. And like I said, places in the Gulf Coast have seen about our snowfall already. So hopefully this recovers. You can see we're 10 to 20 inches of snowfall below normal. Same thing if we scroll down we scroll up, I believe, the precip. You can see we've gotten essentially no accumulated precip. It's all been really light, fluffy snow. So something to watch going forward is, do we get snowfall? Do we get liquid precip from it? I don't know. It doesn't seem to be in the cards for us going forward here. So if you weren't in Madison, you didn't miss much over the break. That's what I want to point out here. Then can we go to our 500 millibar chart, please? So we'll look at the trough ridge pattern from this morning. This should reflect some of the things we were seeing on the loop. And I'll only show 500 because there's something else I want to talk about that's arguably more interesting. So this is a look at 500 millibars from this morning, around 7 a.m. local time. You can see here's a trough that moved through the region. Out ahead of it was our snowfall event. Behind it and right over the trough, this is the really cold temperatures. You can see the coldest temperatures in the United States are Wisconsin, Michigan, and then up into the Northeast. So this is the really cold air, cold shot of air we had from the Arctic. Wasn't the one that brought us minus 13. This was the one that just came on its heels, essentially. And then you can see we're under this maybe zonal slight ridge pattern, which is why it's sunny out today. One of the reasons it's sunny out today, and warmer, and feels warmer. And you can see, looking ahead downstream, really significant ridge, which has seemingly sat over the Northeast Pacific for a while now. It's sort of moved southward. One of the main features for the Santa Ana winds that are going on in California is this ridge that has just sat here. It's moved northward, but it seems like the position is tied to both the weather over us, the weather over the West Coast, and then the Santa Ana winds that have been devastating for California. And that is a look at the 500 millibar for this time. So it was cold with this trough passage, and we're sort of under this ridge now.
I was going to point out, looking at the movie of the sky, just before you started, Patrick, it occurred to me, there was kind of a sharp edge to the really thin cirrus. I'll bet it's the ridge axis. I wouldn't doubt that it's the ridge axis coming through. Because
Absolutely.
right at that point is where if you're further west than that, you have ascent. If you're east of it, you have descent.
I can believe that. It's pretty sharp too, so that makes sense. Yeah, good point. Okay, let's talk about what happened with the snow event, because that turned into something significant for Europe, if anyone follows European weather. Let's go to tropical tidbits for this, please. So the easiest way to go through it. So the same storm that impacted the Gulf Coast is now a significant record-setting storm for Ireland. And we'll watch this evolution here. And could we go to regions, the bottom, and we'll do tropical Atlantic, tropical North Atlantic. And then if we go to runtime, don't look at this. We go to, let's see, 0Z21, I believe. That's right. Check. Okay, yes. Yep, perfect. And let's go to our 12Z. That's fine, 18Z is good. Okay, so what I want to focus on, can we scroll down a little bit, please? This is now looking at, we have mean sea level pressure in the black contours. We have 1,000 to 500 millibar thickness. Those are these dashed red, blue contours. That's showing temperature. And then the green is supposed to show modeled precip. So what I want to focus on here, this is our Gulf Coast snowstorm. Okay, so nothing significant as we talked about. You can see there's a cyclone. This is going in the past. This is valid Tuesday, last Tuesday. Decent cyclone over the eastern Pacific, and then one near Greenland. This is nothing in comparison to these two storms, okay? But it still brought record-setting snow to the Gulf Coast. Not a clear cyclone even, just baroclinicity over a moist region. If we step forward now from this look, as we see the progression, we can see just as reflected in the IR, we can see just bands of the snow moving forward. And then we get, if we go back one, we get the development of a cyclone. 1013 is what the minimum sea level pressure is. So that's right around normal sea level pressure, nothing significant. But this is going to be the making for what becomes a record-setting storm way in Ireland over here. And so we'll watch this progression as we go forward. And at this time, can we go back one? We'll see, we just have a cyclone. I can't even read the central pressure here, but we'll take a look at this cyclone and just switch the model initialization time, please. So I'm switching time just to get a more accurate representation of it. If we go to 12Z on the 22nd. Here. And then, yes, this is perfect. So here's our cyclone, 1,003 millibars. You can see a wide range of model precipitation, very nice baroclinicity in the dashed contours. If we take a cross-section through it, something like that.
Make it perpendicular to the thickness line.
Okay. As perpendicular, we'll go through the...
I think it's a stronger jet than in the forecast than it was in the old one.
And then if we go to PV, we'll take a look. What even is this? Let's see.
Wow.
So here we go, right in the middle. This is our cyclone. Okay, nothing to write home about. There is a nice upper level front, looks like a dip in the PV going all the way down essentially near the surface. But there's a break between where the cyclone is and where this upper level feature is. And I want to argue that this little cyclone is what's called a diabatic rust wave. It is a little low level cyclone. It moves independently of anything going on above it. It's a function of really strong latent heat release in the mid-troposphere, so right around this region. You get a generation of PV below, degradation or weakening of PV aloft, and right in this region you develop a low-level cyclone, and it generates itself based on the precipitation that's going on above it. We have a nice baroclinic zone here, so right downstream of it we would have really strong southerly flow. Encountering the baroclinic zone, producing precipitation, you get that generation of PV below, erosion aloft, and this thing just keeps going. Doesn't need anything in the upper levels, and I'll prove that to you in a second here. But what you can see from this cross-section, we have our low-level PV, positive in the low levels and negative aloft. So this is right where the latent heat release is going on for this storm, and you can see, based on the model precipitation, seems reasonable. You have precipitation ongoing, it's going to release latent heat right where it's being generated, and that's the driver of this storm initially. And this is called a diabatic rust wave.
And what's the core jet speed? Is that 190 knots I see there at about 270
Yeah, that's right.
millibars?
That's right.
It's a strong jet.
Very strong.
And is this is the next day's forecast, and it looks to me like the cyclones moved much farther east. The jet's probably stronger in this forecast package than a prior one, right?
Most likely,
Okay.
yeah. And if we could go back to just the plain view for the same time, if we go to lower dynamics, and 850 vorticity and wind, so you'll see here's our cyclone. It's very obvious cyclonic rotation and strong low-level vorticity. Let's just go to lower dynamics and go to 700 millibars, slightly above where the cyclone is located. Maybe you could argue there's some indication that it's at 700 millibars. Largely, there's just a strip of vorticity. Let's go to upper dynamics and go to 500 millibars. At the bottom, I believe. Yes, there we go. Nothing. This is where the cyclone was. So there's no indication that this is 500 millibars and below. We have a cyclone. Above that, there's nothing really ongoing. There is a short wave, but the cyclone was located somewhere in this region. So it's well divorced from where the short wave is located. So this is completely in the low levels at this time. These things don't care about what's going on in the upper levels. They can essentially generate and propagate themselves without anything else. And that's exactly what's happening. This all spawned from the Gulf Coast snowstorm.
So just to be devil's advocate, can we
Yeah.
go to like 200 and see the wind speeds?
Oh, sure. Yeah,
If they
yeah.
have that? And then point out where the, yeah, so it's kind of not in an exit or entrance region either.
Correct.
But what's the temperature convection along the jet? Do you happen to know?
I don't know.
That's the only other thing that might be a factor, but I don't know if
Absolutely.
it is.
And some of the, we can check this at later times. I want to do other cross sections, but
Yeah.
this thing actually sits at certain times in the jet exit region, but the equatorward side. So where you would expect general descent.
Yeah,
not
and I'll
ascent.
take back the temperature convection thing.
Yeah.
You're not gonna get a local spot of ascent, you're gonna get a band of ascent.
Right.
Or descent because of that, so it's unlikely
Exactly.
that's a factor, so that's
Yeah.
a nice analysis.
Yeah. So low level thing, 1,003 millibars, nothing substantial at all. Okay, let's step forward now. That means a little pressure. Now we can just step forward one click. Now we're at 996, so not too much deepening. Same sort of orientation. We have a nice baroclinic zone. This thing is sitting on the equatorward side. Nice precipitation still along it. Let's go one click forward. Now we're at 980. So we're beginning to deepen pretty rapidly. These are every 6 hours. So that was 16 millibars, 6 hours. Let's take a cross section again, like we just did through this cyclone here. And we'll do PV again. Here we go.
Wow, interesting.
Even more, there's more separation between the upper level PV feature, this low level diabatically generated vortex. And you can see right above it, here's your PV erosion. So this is still a diabatic rust wave, completely moving on its own. It's just left to its own devices until something comes through and can come through and make it rapidly deepen. But at this time, it's still a low-level vortex. You can see that because there's no upper-level feature that's in proximity to it. We have this nice low-level PV maximum, PV minimum above, where you can see it's beginning to erode the tropopause just above it. If we go back out of this view, and we'll do the same analysis of the vorticity. So we'll first start at 850. Now you can see a really strong vortex 2, and then really strong cyclonic rotation around this thing at 850. Nice, you can see the fronts even, where we have increased vorticity along the fronts here. If we go to 700 millibars.
Yeah, I'd say, it's linear at all these levels. That's
Yeah,
the thing that's
that's
so
true.
interesting, yeah.
That's true. A little a little wave at 700 millibars, still nice vorticity. If we go to upper dynamics and 500 millibars, vorticity. Here's where it's located, but here's the upper level wave. So this thing is still by itself, and it's still rapidly deepening. Doesn't care about what's going on above it. It's just moving and deepening along by itself. And these things happen all the time. What doesn't happen is when these things correspond to an upper level feature and the two can go to work together and then they produce record-setting storms, and that's what we'll see as this progression continues here. So if we could go to back to the precip, sea level pressure. We're at 980. If we click forward, please. 968. You can see we're beginning to wrap up the thickness gradient, so producing a thermal ridge. Really nice band of precipitation, which is still driving the bus for this thing. Go one more click. 957. One more. This is pretty accurate to what happened, which is why I'm showing it. 945. Now let's take a cross section, if we can, through this thing. Like that. Perfect. And we'll do PV. Here we go. Now we have a connection between something that's going on in the lower levels and the PV trench that's coming down from the stratosphere. These are this is tropical tidbit, so it's not the best look, and it might be a function of the cross section, but you can see there's a connection between low level PV extending all the way up into the tropopause and into the stratosphere. Still really strong PV in the lowest levels, so you can still argue that this is a dieback rust wave. It's just now connected to the upper levels. That's why it gets down to 945 instead of continuing to move on and maybe moving a different way. That's the theory behind these things, is eventually they get picked up by the upper level wave, and that's what portion of the reason it moves poleward at this time. If we click out of this look, this will be the last thing I show. Here's Ireland, and here's this system. Go one more click, put my cursor on Ireland. This thing moves completely past Ireland. This is 1 a.m. local time, so this already happened. The storm is now over Scotland and the UK. It's called Winter Storm AOS, E with an accent over it, AOS. Set the all-time Ireland wind gust record, 114 miles an hour. Wind gust. So this is like Category 3 hurricane, and it's an extratropical cyclone that produced snowfall on the Gulf Coast. A station in Ireland recorded 941 as the minimum sea level pressure. So this is a pretty good model representation of what happened, and this is a 42-hour forecast. So record-setting storm in both the United States and then in the UK and Ireland. So pretty cool that this thing happened. And that's the main thing that I want to talk about. Yeah.
That's really interesting, Patrick. Great job. This is so unusual in this. I mean, you said, I'll agree with you, it is usual. I shouldn't say that it's unusual, but here's what I mean by that. There's really no, at least in what you showed, there's no particularly strong upper dynamics driving this thing over its entire life cycle till it gets to be this record-setting storm over the Irish Sea.
That's right.
Usually they have a period of time where they develop, and then they're picked up, and that's where they get pushed over the hump, but not this time.
Right.
This is a really interesting event, and I'm wondering if the November 19, 20, 2024 event looks like this. But it had strong upper forcing, but it also had this extraordinary development that it underwent without, it just, how did that all happen? There's something weird going on with some of these storms.
I agree. It seems like Goldilocks, where this is just the perfect setup. Anything else? Any other, the upper level wave, maybe it moved over this thing and it actually weakened. I don't know. It didn't happen. What if this thing didn't get caught up with an upper level wave? Would it have been this strong?
Yeah.
Don't know. Would it have gone towards Spain? Not sure. It just seems like they came together to produce something we have never seen before, this strength at least.
One really simple thing that I have in mind right now is that if it's mostly the diabatic heating, which you suspect because you're kind of saying it's a diabatic Rossby wave development throughout its entire life cycle, and I don't see any really strong upper wave where you'd have big bullseyes of ascent and descent, but it would be easy to see what the QG omega said about this evolution,
Yes,
and then
agreed.
see how much development potential there is just in that. It may not be sufficient because I'm keeping the stability constant. It doesn't react to that. It's only responding to the curvature in the flow and or frontogenesis. Frontogenesis could be strong here, but that never produces, local isotropic regions of ascent.
Right.
So this would be really a first order way of seeing whether or not this is well beyond the QG system to try and understand the development here. Really interesting.
I think it would be. If we step back, to what it's like over here, that's perfect. And take another cross section real quick. The stability struck me because I read a study about these things that go to potential vorticity is great, and then submit. The reason they keep generating themselves, just you can say static stability, whatever. You can see here's the isentropes, so relatively this amount of spacing. As they move towards the latent heating, you get a dip going below and an increase aloft. So keeping static stability constant wouldn't work. It just doesn't accurately represent. And then
Absolutely
because
right.
you increase the static stability in the lower levels, you're compressing these isentropes together. That's one of the reasons PV increases, is because you have an increase in the static stability. PV is vorticity times static stability. So I don't think it would happen. Plus these are really small scale, so I don't know if this would even be picked up by something like that.
The other obvious thing with your infrastructure that's already built is to get the ERA5 data again and do
Yeah.
what you did before.
Absolutely.
And just
Yeah.
see what's going on. I imagine that tower is the whole storm.
It seems like it is.
And maybe a little bit of an assist from aloft. Maybe
Right.
maybe upper levels provides at least a conducive environment for upper divergence, but it doesn't drive the upper divergence. There might be a difference there. Yeah.
Good point, yeah, because it's completely zonal until these things connect, so maybe that is, it's just letting it go by itself.
And you let the air go up, and you're on the inertially unstable side, on the equatorward side of the jet.
Yep.
It's maybe easy to move that air out once you lift it up, but you're not really doing the lifting
Yeah.
by virtue of the upper dynamics. You're providing the highway to get it out of there. Maybe that's the way that
That makes total sense to
we
me.
put it together.
Yeah.
Wow, it's really interesting.
Any questions or comments before I pass it over? Okay.
All right, thanks very much, Patrick. Great example of how what you're doing in your research shows up in the weather maps. You just have to go far. You gotta go talk about it. I mean, that's just really nice. And staying within the time limit. We could have done some other things to look at it, but just looking at the thickness field, there's no particular reason to suspect there's an upper wave involved in this, because there'd be a deformation in the thickness field that you'd see too, and it would evolve that way. So, very, very interesting case. Okay, I'm gonna just give you a brief forecast for the coming days, but I haven't been able to look at it ahead of time. But I wanna start out with,
You gotta unlock it.
the cold pool for December 1st through January 22nd. The semester ended before we got to the beginning of the real cold season. But you remember the fall was the warmest fall ever, September 1 to November 30th. We've never had a warmer fall. And warm being minimal aerial extent of the -5 air at 850 millivolts. So we had the smallest integrated area over all those days at 850 that we've ever had since 1948, so 77 years, okay? This is now the time series for December 1st, 2024 to January 22nd, 2025. And this is the average, the daily average aerial extent over the last 70 years. This is +1 standard deviation, this is -1 standard deviation. And these are the all-time maximum for the day and the all-time minimum for the same day, so those little thin blue lines. We started out way below, actually well into the 2 standard deviation or bigger, below the average. In the beginning of December, we kind of came back. Look at this period. This happened at Christmas time. It's one of those awful things, you know, where you have to keep your excitement to yourself, and I didn't even tell anybody about it. But these little yellow dots, as you can see, are days on which in 2024, we set the all-time minimum for that calendar day, which I think is December 23rd or 4th. 1, 2, 3, 4, 5, 6, 7 straight days at the end of December were the all-time minimum 850 milliwatt -5 air aerial extent. That's unbelievable. Okay, you get occasional records. To get a week long at the beginning of a week after the solstice, simply unbelievable. And then, boom, we come back up. Well, you might think, oh, that's a huge increase in the cold air. Yeah, put us at 1 standard deviation below on January 1. And then we kind of crept up almost to the average, and then we had a record recently about a few days ago. When you take the difference between the average and this value, and you add up all those differences, you can kind of rank the years. And it turns out that to January 22nd, even with this giant excursion back up almost toward average, we are the 5th smallest aerial extent from December 1 to January 22nd ever. And number 1 was 2014-15. That's the warmest year we've ever had in this record, December, January, and February. And then the next 4, of which we were the 4th, are fractionally different. So we could be the 2nd warmest if, an area the size of the state of Tennessee were different over these 22 or 52 days. So we're challenging for number 2, and we may, with this much time left, we may well challenge for number 1. It's never before happened that the warmest fall was followed by the warmest winter. So if that happens, there's gonna be a flurry of executive orders coming out of Washington, D.C., I can tell you that right now. So that's gonna be kind of scary. We are in a weird situation here that has never happened before. And so I'm gonna keep a close eye on the next, 35 days or something like that. It's gonna be so much fun. Another thing that's interesting about the cold pool, some years have great volatility, ups and downs. And I had a measure of that I won't talk about today, but there doesn't seem, at least at first glance, to be any particular connection to anomalies in the circulation and increased volatility or decreased volatility. But that's very, very cursory. And I'm not really well versed in the stats. There might be a better way to do look at that problem than I've thought of myself. So that's another interesting thing that somebody who's maybe interested in how the whole hemisphere is reacting to the background warming might want to take up. So anyway, what an interesting time series so far this year. And it puts us at number 5, but barely. We could be number 2 at this point, fairly late in this 3-month stretch. And we're more than halfway there. So that's interesting. Okay, thank you for letting me show that, Pete. And let's take a look at the forecast. Let's go to our own Pete maps. And we'll start at 500 millibars at maybe 18Z, so a 6-hour forecast.
518 Z.
Yeah, 6-hour forecast. So we just get a sense of the complexion of where we are. So here's about noontime right now over the continental United States, Canada, and adjacent waters. So a couple of the big features are wave/vortex strip. So it's a combination perhaps of a strong wind speed maxima along the southwesterly flow and then a couple of little embedded waves that adds up to these local vorticity maxima, both shear and curvature added together. Again, a combination shear and curvature in this location off the Washington coast, or right along the Washington coast, I should say. Big ridge in the Gulf of Alaska, and then a trough upstream. Here's Hawaii, and this thing manifests itself in the satellite picture as kind of a broad-scale circulation with convective-looking clouds on the eastern side, and then some lower stratocumulus-looking clouds on the western side. Not at all uncommon. I just pointed out that you could see this also on the satellite picture. And then one gets the sense that there's a whole bunch of different waves of varieties of sizes. Some of these are the so-called tropopause polar vortices, most likely. I can't say that I know that. Andrea has a tracking algorithm, so she'll be here next week talking to us probably about that. And we're about next week to start early morning meetings of a dry run of a program that's going to go on next winter time, where we're going to be looking at exactly the high latitudes and trying to take a look at these tropopause polar vortices, how they impact weather both over the eastern half of the United States and then downstream over Europe. So I'm hoping that we get a couple of cases where we have a nice Alberta clip that starts out with one of these upper disturbances, comes across weakly over us, gives us a dusting of powdery snow, explodes over the northern edge of the Gulf Stream, and then is in the 940 range over the British Isles or Western Europe. That happens frequently. So if it happens this year in our dry run and next year in the field campaign, it'll be a thrill. We'll have a really great data set. 7 straight days. Exactly what you're talking about, Patrick. We had the capability with the things that are arrayed for the field to look at such a thing, if it were captured well in the forecast, start down here with the hurricane hunters and go all the way across the Atlantic and look at that thing. Oh, would have been great to get that storm that you just talked about. Maybe we'll get one like that next year. So here are the features. Broad scale trough to our west, kind of sharper trough going off the coast, and a fairly small, fairly large scale and sharp ridge off the west coast. So let's take a look at how this evolves maybe in the next 12 hours. The big thing I think we're all hoping for is a warm-up. So we want to see a change in the nature of the circulation over our state. I can see right now that's going to happen. I'll tell you why I say that in a minute. But that's the big thing. We've had an extended period of really sub-average temperatures, topped off by the -13 on Tuesday. That's really cold. And so I like visitations by, it's like a visit from your in-laws. It's nice for a few days, but it's time to leave. You know, so that's kind of how it is. But look at this westerly flow right across the western 2/3 of the United States. Anytime the flow's from the west at 500 millibars, we're warmer than normal, or at least climbing back to normal. And so right away, I have great hope for that. Even in the face of this strong northerly flow coming right out of northern part of Alaska and Canada, making it all the way down to South Dakota. The westerly flow here is just so helpful to warm us up because we've got the Rocky Mountain Massif right here and the flows going across it. There's downstream subsidence and warming. I'll bet you it's relatively warm at 850 over the plains at this time. And but this ridginess does get me concerned. One of the conceptual models for the intense development of upper fronts involves a ridge over the west coast, some sort of a trough impacting at the crest of the ridge. Confluence here really drives this increase in the temperature gradient, and then it comes down on the northwest side and continues to get more and more intense as the vortex structure digs out a trough, and we're open to the cold air to the north. So that's maybe 3 to 5 to 7 days out, but the immediate time, early part of the weekend, westerly flow here is great, going to warm us up. So let's take a look at 850 at this point, Pete, and see what we see at that time. Okay, so remember the westerly flow is right about here at 500 millibars. There's just a hint of a little bit of warming. That might be subsident warming. over the southern part of the Rockies. It's not really in the front core of them, as you see there. Cold advection is, well, I should say cold flow coming southward, but the advection is weak. It's really, really cold over the western archipelago, but the gradient is not very substantial. And so, though the cold air lurks, it doesn't seem to be replenished readily over us. And in fact, it might even argue there's slight warm advection for us by midday, or even by midnight tonight, right at the southern part of Wisconsin. Let's go 12 hours further ahead. Broadly speaking, over the continent, fairly boring, but that's the features to keep an eye on. This vortex structure, both a strip here and then a little upper wave, poised around the ridge, the crest of the ridge, and comes straight down a northerly flow. Gets me a little bit nervous. I don't see a persistence of the strong westerly flow that we saw a minute ago. So by about midday Saturday, I don't expect the temperatures to be any warmer at 850 than they were in the prior map, but maybe that won't be the case down over the southern plains. I think it will warm up there. Let's take a look. Yeah, temperatures aren't that different over the Great Lakes states, and there's really not much warming going on over the plains either, and the southern plains, I mean. Relatively warm over New Mexico and Arizona. Desperately cold over Alaska and the Northwest Territories. And here's a reflection at 850 of the leading portion of that upper vortex structure. That thing is the thing that can be the pivot point to drag this really, literally bloody cold air southward for us. And the ridge remains fairly strong off the coast, which I think imperils that eventuality, really makes that a likely scenario. Let's go 12 hours further ahead. Okay, so things are not changing substantially. There's this wave over northern and central California is taking better shape. It's kind of a residual vortex piece from the strip that was aligned along the westerly flow at the initial time. And then here we see our feature cresting over the ridge and the front edge of it curled up, and that's where our cyclone is over the archipelago at 850. And so very much colder air to the north of that feature. So this ridge axis has gone from that orientation to one that's now maybe breaking over itself over the western part of the United States. Grant can tell us a little bit more about that maybe. Where is it? There it is. So in the middle of late part of January, breaking ridges over the coast of British Columbia usually mean it gets cold over the central United States. Let's see if that's true. So we'll go to 850. You can see the cold air is expanding over central Canada, northern Canada, and there's the cold air that's forward of the wave. But broadly speaking, things haven't changed very much over the Great Lakes states. And then the cyclone over California has a little bit of a warm advection tongue into Arizona and New Mexico. That looks just like what we saw before. And then here you can see an obvious lee side warming in the British Columbian Rockies and the Alberta Rockies with the flow coming across there at 850. Okay. Let's go 12 hours further, Pete. Okay, so this thing becomes fairly stationary right over San Francisco, it appears, and then all of the vortex structure that was cresting over the ridge has gotten to be a little bit more linearized. Makes it look a little less foreboding, especially for our longitude. So this is kind of, there's an upper front in there, undoubtedly, and there's probably some development along it. But that development's going to carve a trough out that maybe makes its way over the eastern part of the Great Lakes, not so much over us. And so the ridge seems to be expanding in its aerial extent and slightly moving eastward. And if it's going to put us in the downstream side of that, it'll be chilly, but it won't be bitterly cold, because I think all the cold air is trapped on the cyclonic shear side of this feature here. And we'll see if that's true at 850. Seems like that's roughly the case. The warming in the lee of the Canadian Rockies has expanded a little bit into the prairie provinces. We haven't changed our temperature much. We've been in the minus, I think that's minus 12 range at 850 for the entire series of maps, which now goes some 48 hours. And things haven't changed much in the southwest. So this is kind of a stationary temperature map in the lower part of the troposphere while the flow is evolving subtly but obviously at upper levels. I think the most obvious change, though, is the encroachment of the relatively cold air here into northern Ontario, northern Quebec, and it started out being relegated to the archipelago. So that's spread southward, but eastward, not southward over us. And that's good news, I think, if we don't want to remain cold. I'll point out a really strong region of warm advection over the southern central provinces of Canada. Probably not accompanied by much vertical motion because it's almost uniform temperature advection, and that doesn't give you any QG omega. So I think it just generally warms up a little bit over the western provinces, but doesn't really, and maybe even parts of the Dakotas, but it doesn't really get cloudy. And so that's interesting. One more time, Pete, because we got to get out of here at 1 o'clock. So one more 12-hour increment. Boy, everything looks relatively stationary with respect to the really prominent features, although this has gotten much lengthier, this vortex strip. The flow is intense here at 500 millibars. I'm going to look at the jet at 300 in the last panel just in a minute, but I'm going to guess it's in 150 or something not range. But it's directed to our east, maybe just barely, but to our east, and that probably saves us from the really cold air that's getting itself organized, I think, over Hudson Bay and parts of Quebec and Ontario. So we don't get a flood of really desperately cold air, it does not look like in this panel. And then cutoff remains it's sort of sagging southward along the California coast. And I want to take a look at this last time, first 300 millibars, just to get an idea of where that...
66.
Was it 66? Yeah, 66. So 150 knots right through the central prairie provinces at 300 millibars. And that's a pretty strong jet. It'd be nice if they had the temperature on here, maybe 500 millibar temperature advection along the jet. I don't know what the answer to that is. Depending on the temperature advection along the jet, you either have subsidence through jet core or ascent. And so either one will greatly change the complexion of the weather in the affected region. Hard to know from just this. And then let's look at the surface map. I want to see whether it's precipitating over, in the forecast over the San Francisco Bay Area. Not surprisingly, it's quite weak. So this thing, remember, was a little vortex strip that kind of got peeled off at the far western end of a strip that was aligned across the country. So it's not really had an opportunity to ingest a lot of water vapor from far southern latitudes, and it's kind of struggling to produce any substantial precipitation over the Central Valley. But it's not zero, it just won't be flooding, which is good for them. Here's a really nice case of extremely strong thermal wind, most likely a vortex feature right in this location that we saw at 500 millibars, and PVA by that is leading to the development of a modest cyclone to the east of James, or the west of James Bay, 984 millibars, weak precipitation. It is the kind of feature, though, for the purposes of the field program for next winter, that looks really innocuous now. Gets out over the warm Gulf Stream, or even the warm Atlantic Ocean, it's not even the Gulf Stream, this far latitude, and then suddenly explodes, not only because there's an increase in the available water vapor to fuel the latent heat part of the development, but the organization of the upper wave gets better and better and better. And so you get both things happening simultaneously, and you can, doesn't always happen, but you can get a big explosion of cyclogenesis in those cases. Starting from, boy, all you're talking about here is the barochronicity, there's not that much about a circulation. Watch out, maybe a day later, it's a big difference. In fact, last thing, Pete, one day ahead. Let's go to 06C Tuesday, see what it looks like.
At 500?
At the surface, just to see. 12 more hours, please. Maybe that wouldn't be enough, we'll see. Getting close to the coast. 976, let's go a whole day out from here and just see if this thing, when it gets out over the Atlantic, does anything more intense. No, it never gets out over the Atlantic, so this one doesn't get there. It gets captured over the land. Gets more intense, 968, pretty intense cyclone, but I don't think it has any downstream consequences in this particular instance. Okay, so maybe the jet has to be a little bit further to the east to really drive it out over the Atlantic. Okay, we have to go. Thank you, Pete, thank you, Patrick, and we'll see you all next week. But
Next week, we might start closer to noon.
Yeah, okay.
Just because there's a class in here at 1 o'clock right after us, and next week we might have Michael Morgan with
Yeah,
us, too.
the secretary himself will be back, it looks like,
Yeah.
so we hope to have him back. So that'll be great. See you all then, thank you for coming.